Hello, everyone. We're going to give it a few more minutes until we start, since you can see more people logging in. So we were going to start in a few minutes. Hi, everyone, and thank you for joining us today for this joint webinar by Cybellum and PTC. With us today are Michael Engstler and Markus Kreutz. Michael is the co-founder and CTO of Cybellum. He has years of experience service as an officer with the Israeli Elite Intelligence Corps in various R&D and management positions. For the past 3 years, he has been working with the largest OEMs and automotive suppliers, helping them put in place an effective vulnerability management and risk assessment solutions. Markus is the head of sales and systems software engineering at PTC. Markus has more than 20 years of experience in the system engineering business in several roles, starting from software engineering, pre and post-sales roles included. He has been serving in different responsibilities in regulated markets, including medical devices, defense, and automotive. Please feel free to ask us any questions as they pop into your head. We will answer them all at the end of the webinar. You can do that by clicking on the Q&A button at the bottom of your screen, and then just writing your question and we will see them. With that, we're ready to start. Michael, the floor is yours.
Hi, everyone. Let me introduce you to Cybellum. Cybellum is an automotive cybersecurity company with a mission. Our mission is to enable OEMs and their suppliers to develop and maintain secure connected components. We are able to provide them that value by three main pillars, which I'll introduce now. The first value pillar is the ability to comply with compliances, security, policies, and regulations. Using Cybellum products, we enable OEMs and their suppliers to understand exactly what are the requirements from the standards and regulations, to test their products to see if they comply with the requirements, and if not, to understand exactly what needs to be fixed in order to comply with these regulations. The second pillar that we focus on is providing full vulnerability management throughout the entire product lifecycle of the automotive components. This includes vulnerability management throughout the entire stages of early design, throughout development and testing, and until start of production at SOP stage. And lastly, we provide the ability to perform continuous monitoring and incident response post-SOP. This gives OEMs and their suppliers the ability to identify any types of software vulnerabilities that are affecting their products, to understand exactly which components and cars are affected, and to handle them accordingly.
Thanks, Michael. So I take this slide. So thanks for having me in this webinar today. Thanks for the invitation. So give me a few seconds to explain who PTC is and why we are doing this jointly. So first of all, PTC is a US-based company headquartered in Boston, and it's a worldwide company, a subscription company focusing on SaaS solutions. And what PTC is motivating and driving is the term what we call power to create, which fits well to our company name, we think. So it's all about how we can improve engineering and manufacturing customers' processes and development. You may know PTC from CAD tools, computer-aided design tools like Creo, or most recently Onshape. You may have heard about our leading technology of industrial IoT, the ThingWorx platform combined with augmented reality and spatial computing. And today we focus mainly on a topic which belongs to the PLM segment, so the product lifecycle management. We from the business unit at PTC, from Systems and Software Engineering, or short SSE, we have two core products. You see them on the right side. One is Windchill RVNS. RVNS stands for Requirements Engineering, Validation, or Test Management, and Source Code Management. So this is the standard tool at PTC for this kind of engineering disciplines. Requirements, any type of requirement, any complexity from a high-level requirement may be decomposed to a software, electronic, electric, or mechanical requirement. The same for test management. And all is traced inside the tool together. That means we can easily identify which source code change was done because of which requirement or which task or which defect. Not a topic for today, but also interesting is the second core product called Windchill Modeler. That's a tool which helps companies in the space of model-based system engineering. So defining the system needs based on SysML. It also includes a component for software design or software modeling based on UML. And this all combined with code generation as well for our industrial IoT platform ThingWorx, plus system simulation and co-simulation for early validation in the engineering cycle. Also here we have great traceability, and I think, Michael, if you please go to the next slide, I will explain what digital product traceability means for us. So what is it about? So as I mentioned, all these tools at PTC have great traceability, but based on the complexity of our customers, we see another level needs to be reached. That means complexity in terms of there's more software included in the products, especially in automotive. We see more lines of code. The industry is talking about software-defined cars. That means also there's an extended supply chain with a lot of suppliers. There is most recent technology need to be quick, and also as well, this needs to be go hand in hand with quality and costs. Now think about your engineers need to figure out what kind of impact a change may have, or think about early to identify the risk or possibilities or disadvantages by changing something in the system. That's all about traceability. So it's like a V model, what you see here, very simplified as a schema coming from the left side. You have the green one, the requirement may be connected to a functional or logical structure, but finally maybe part of the bill of material, the engineering BOM or the manufacturing BOM. So easy navigation to figure out why does my product behave like it does, or why does it look like it's look like. That means engineers should be in the place to easy access this kind of data, to see the reasons, to see what are the changes which belong to. And all of this needs to go hand in hand with regulations. Companies need to be compliant. So on top of the product engineering complexity, we have also a regulation complexity. From the past in automotive, we know about ISO 26262, safety related requirements. Our product is TÜV certified for this, for example. And today with Cybellum, we will hear about a new or actual hot topic in the automotive market of cybersecurity. So what we want to do with our partner, which we announced in January jointly, is that we integrate what Michael will present us in a minute. So that the solution becomes from the early requirement down to the cybersecurity aspects, a full trace solution. And I'm happy to talk about digital product traceability today jointly with Cybellum. So Michael, I hand back to you.
Thank you, Marcus. So a lot of times we get the question, why now? Like, why cybersecurity and automotive now? Automotive industry has managed, let's say, for more than 100 years without too much cybersecurity, and everything was fine. Cars weren't falling off bridges or anything like that. And I would say that the main reason that cybersecurity is such an important topic these days is because cars are practically becoming full of software. And these software includes software problems, software vulnerabilities that can be exploited by remote hackers. Today, an average car has between 150 to 300 million lines of code. Now, just to get that into proportion, the F-35 fighter plane has about 100 million lines of code. So a typical car has more lines of code than a fighter jet. And each one of these lines of code can potentially introduce a new vulnerability that may be exploited by a hacker. Moreover, according to a Forbes survey, as of today, every large automotive manufacturer has been hacked in one way or another, whether it was an IT or internal hack, or whether a penetration hack for one of their vehicles. So this is something that is not far from us. It is happening now these days. And a solution is required for that. And moreover, and maybe one of the main reasons why we are gathering here today are the main new regulations that are headed our way. The two new main regulations and standards are the WP29 and the ISO 21434. Both of them are for automotive, for cybersecurity. And as you can see in the timeline below, these standards and regulations are much closer than what we might think. For example, ISO 21434 is going to publish the final draft during Q3 this year. The WP29 will become mandatory for type approval for new vehicles in Q3 next year. What this actually means is that every new model from Q3 2022 that would like to adhere to the WP29 regulation would need to do that by next year. So as you can see, the problems of cybersecurity and automotive jointly with all the regulations that are coming in place are requesting a solution that is able to help provide answers for that. And now, before we go on, we have a short poll. Adi?
Okay. 1 second here. Please take a moment to read the questions and select your answer, and then we will present the results. We'll give it a few more seconds. Okay, I'm about to close the poll so we can continue with the presentation.
So hopefully we have good feedback.
Yes, well, we'll see in a second.
Perfect.
Okay. Can you see the results now?
I do.
So 41% answered that we are in the question was, how prepared are you for the new standards and regulations coming into effect? 41% answered that we are in the midst of preparing. 24% we are ready to start implementing the necessary processes and technologies. 12% we have a project plan for later this year, and 24% this is not yet on our roadmap. 0% we have automated the entire process and we are ready for the regulation.
That's quite interesting, Adi and Michael, because what we realize here is that more than 50% are on the way to it. Of course, we do not know if it's an OEM, a supplier, and so on, but we see that most of the attendees are working somehow actively on that. So that means it's an ongoing topic.
Yeah,
okay,
definitely. Okay, I will move on. So we managed to establish why now, and also to give a brief presentation about the regulations that are coming. I would like to discuss a bit about the challenge, though. Cybersecurity traceability for automotive is not an easy task. And the main reasons for that is that in order to perform product lifecycle traceability, you need to be able to trace and connect between, on one hand, software vulnerabilities that are detected in components, all the way back to the actual vehicle type, its components, and even the original cybersecurity requirements. And this is not an easy task at all. And I think that today, when we present our joint solution with PTC, this will be one of the main value points that we are able to provide together as Cybellum and PTC. The second challenge is also that the number of products, and mostly the number of version per product in new vehicles, is becoming larger and larger every year. If let's say a decade ago, you barely had over-the-air updates or new versions, today you can see companies that are working in Agile, that are releasing new versions every month, or even every couple of weeks, are updating them over-the-air update systems, and are updating them for many more products in a typical vehicle that can have up to 100 firmwares today installed on them. Each one of these different components needs to adhere to the standards and regulations, and needs to have cybersecurity practices and processes. And this is obviously not something easy to do at all. Lastly, is also like the extended product lifespan. If in the past you would just finish a vehicle and you would ship it out and that will be over, today you need to continuously monitor it for new software vulnerabilities, so that if a vulnerability comes out, you need to understand which of your vehicles are impacted and exactly which components inside the vehicles are impacted. And according to that, you would need to offer a patch or an update in order to mitigate the threat to the vehicle. And sorry, this is the last one. And the last point, and maybe one of the biggest one, is the challenge of the large supply chain in automotive. I guess it's not new to anyone here that the automotive industry has usually a very large supply chain. You can have an OEM with dozens of suppliers, and these tier ones with also dozens of suppliers, each one adding more and more code to the final firmware binary that is going inside the vehicle. And each one of these suppliers is protecting its own IP, so the access to source codes is quite limited. And the ability to perform all of these cybersecurity actions in this complex tree of supply chain is something that is very hard. And one of the solutions for that is to perform the cybersecurity actions on the final binary. The final binary that includes all of the code that was included from the entire supply chain. And this is exactly what we are doing in Cybellum, and I'll present it now. So introducing Cyber Digital Twin. Cybellum has developed a unique technology called a Cyber Digital Twin. It is our proprietary technology that is able to take binary firmware files of automotive components. It can be infotainment systems, ADAS, braking systems, whatever. We are able to create a complete identical digital replica of that component. And that digital replica would include the entire software bill of materials, the entire hardware bill of materials, all of the interfaces, configuration, everything that is needed in order to create cybersecurity actions on that digital twin. Later on, we will be using that Cyber Digital Twin throughout the entire life cycle of the product. So we will start as early as the design phase, where you start to design a new system. And there you would define the requirements for your system. You would define the software bill of materials, the expected hardware bill of materials, and so on. And later on, during testing and development, we will continuously test that Cyber Digital Twin to detect any new types of software vulnerabilities or security issues that needs to be fixed. If a software vulnerability has been detected, we will also provide a full step-by-step instruction on what needs to be done in order to, first of all, properly understand the impact of that vulnerability, but also what needs to be done in order to fix that vulnerability. Now, we will show soon a use case of how joining Cybellum's Cyber Digital Twin technology together with PTC's product lifecycle management is able to provide a full cybersecurity traceability in a way that hasn't been possible before. So Marcus, I'm passing it on to you.
Thanks, Michael. So what is the idea? So you heard before about the digital product traceability idea, and here we are talking mainly about our product Windchill RVNS requirement validation and source. So the idea is starting from the left as a high-level process in the implementation we have done in this partnership. You see at the first step, defining any type of requirements of the component of the system you need to develop. Can be complex, can be different layers, can be decomposed in several levels. And related to that, we have traces included to the test cases. There could be test libraries, there could be templates, but finally there will be other objects like test objective, test session, and things like that. So at the beginning, there is the definition of what needs to be done. This can be in parallel, for example, to 26262 requirements. We can have in parallel and trace them to 21434 requirements. So all on one platform and related as needed. Then usually there will be a source code or the binary, like Michael said. So assuming an OEM will receive from his supplier the binary, this will become versioned. So this will be moved into the repository. There will be a link, of course, to the data because it's a planned release. It's a planned release project. So that means it needs to correlate with the requirements, with the test cases, maybe with the changes which needs to be done. And this is versioned and safe in the system. So if all this is prepared on the Cybellum platform side, there's a possibility then, of course, to prepare the security scan. So there may be different parameters which needs to be chosen depending maybe on the ECU architecture and the behavior of the system. So if all these parameters are set, we move on to step number 4, which is conduct the scan. So then all the logic and the smart way of the Cybellum platform will be kicked off. Many analyses can be done. And then after a while, we will see the reports. Of course, in the Cybellum platform itself, there will be all the detailed results. You see here a screenshot about a security score, which is a kind of summary. But we will see later what this kind of report look like. For traceability purposes, so we have, of course, the direction coming from a test session, starting on the Cybellum platform side. That's one direction. But when the test is done, we also bring back data. We don't want to replicate the data. So we just take the security score and we have a link included to the reporting, and a summary will be attached to the system. So in number 7, we see if in the test session, if the test was successful, if there have been some risks, if there are any problems, maybe also critical findings. So with step number 8, this means depending on the criticality, several actions can be taken. So first of all, there could be, of course, a normal information about the scan is done. It was a complex scan, it maybe take a while. It could be that's a critical one where a bug was found, which is a serious one. So that means depending on this kind of assessment, the system can make a decision and, for example, inform all the product owners more or less in real time about there is a critical bug found. We need to think about how to deal with that. Michael mentioned it already. There's maybe a perspective during the development where maybe the criticality is not as high given as all the cars which are out of the door, which are in use at the customer. At that moment, it's of course very important to be very quick and kick off procedures to make a decision what needs to be done with the cars on the street. So because of that, it's important to get very quick and very precise and information more or less in real time, 24/7 a week. So the idea is here coming from a high level requirement, moving down to the execution, bring back the result, and then handle specific actions depending on the findings. Michael, I hand back to you. So what will happen then? How does the report look like?
Yes, thanks, Marcus. So this is how a general overview of the report looks like. So first and foremost, you would get a general security score. Now, this security score would let you know what is the risk score of the device. So 10 meaning there's a lot of risk, it's not good. 1 or 0 mean that the risk is pretty low or non-existent, and that is what we are aiming for. So for example, let's say you will take your first binary and you would scan it and you will get this score here, which is 6.86, pretty high, something that you would need to attend to. Apart from the score, you would also get a detailed actionable report telling you exactly what are the software vulnerabilities that were detected, how critical is each one of those vulnerabilities, and how do they impact the score? How did we reach the 6.86? And what are the steps that are needed to be done in order to remediate these vulnerabilities and lower the score? And once you receive a new binary, this is back to you, Marcus.
Yeah, and then exactly. So if we have the findings and this analysis is done, and of course there need to be fixes. So a new version, like Michael said, will be compiled. And this version then finally, we added here step number 9, will be sent back in our example, maybe to the OEM. So that means he will take the new version, he will add it to the repository so that no step is missing. It's automatically linked to all the requirements and all the changes, maybe also the defects which has been found. And then we can kick off again a scan. So that means it's an iterative process, and all of these scans and results and change requests and defects are tracked in the system. So for compliance, this is very powerful. So you can pick from a requirement the results and say, how often was this requirement tested, for example, or what happened with the critical finding during the last run and how was this mitigated, like Michael described. So that's exactly what the assessors for compliance would expect, a full traceability. Handing back to you, Michael.
Yeah, and our goal eventually is after we perform this iterative process, which might take a few iterations, and you might not reach 0.0, but also reaching 1.0 is better than 6.86. You would eventually reach a point where the risk of your device gets lower and lower over time. More and more vulnerabilities are fixed, and this is something that we expect you to do constantly with your supplier and your development teams in order to ensure that all of your components are all well below the acceptable risk score for your products. Now, just to describe a few key benefits generally of using Cybellum, and particularly here together with PTC. Indeed, one of the main advantages is the ability of reaching full traceability. So gaining a full cybersecurity traceability throughout the entire product lifespan. And this means that if you are able to detect a new vulnerability that is published and is affecting one of the vehicles or a couple of vehicles in your fleet, and you're able to trace it all the way back to what vehicles are affected, which components inside the vehicle are affected, and even what cybersecurity requirements that were defined at the very early stages of design are affected, this gives you a very powerful ability in order to create proper traceability for all your cybersecurity requirements. Second of all, and this is also something that we discussed quite a lot today, is meeting compliance. And that is both WP29 and the ISO. Our products gives full support both for OEMs and their suppliers to understand, to test and verify, and also to understand what needs to be changed or fixed in order to meet these standards and regulations. Reducing risks, obviously, in order to not become one more of those companies that were hacked according to Forbes. So reducing risk overall for the entire vehicle as a whole, but also on a component level for sensitive systems such as infotainments, telematics, ADAS, or even more safety-related systems such as braking system, steering wheels, and so on. And last two key benefits is also cutting manual labor and time to market. I guess all of you are quite familiar with the shortage with cybersecurity personnel. The more you automate, the more you will be able to cover more components, more vehicles, and be as ready as quick as possible to adhere to all the compliance and standards and regulations that are coming and will be mandatory in the coming years. Just a brief glimpse at our credentials. We are pretty market proven. We are working with quite a lot of OEMs and tier ones. This is just a small sample of the ones that we feel comfortable publishing. And we are also very active in standards and alliances, including the ISO committee, Auto ISAC, ASRG, and not only from the automotive side, but also from the cybersecurity side. Cybellum is an official CNA. A CNA is an organization that is allowed to publish CVE vulnerabilities by themselves. We are part of this prestige group together with Google, Microsoft, Apple, and about, I think, less than 150 companies. And lastly, we have quite a large global reach. Our headquarters are located in Israel, in Tel Aviv, but we have offices in USA, Germany, Japan, and China, and partners in Korea as well.
And with that, we are done with the official part of the presentation, and we would love to answer your questions. Again, questions are logged in the Q&A tab at the bottom of your screen. We will go through them one by one.
Yeah, and it looks like we have already a few of them.
We have already a few of them. Yes.
I answered already one, so it disappeared from my screen.
Oh.
So I hope the answer was sufficient. If not, please reach out again. The question was to slide number 10. In which steps is Cybellum, the Cybellum product included? Oh yeah, thank you. Yeah, it's fluent from 2 to 3. Of course, there's a project on our side, there's a project on the Cybellum side, which need to be connected. But then, of course, if we have everything prepared on the Winchell RVNS side in terms of what needs to be done, let's say the test objectives, the technical stuff needs to be done on the Cybellum side. And that's then step number 3. And we are then returning from an integration point of view at that moment at number 6. That means where we have just a summary in Winchell RVNS in the test result to make sure the loop of traceability has been closed. So that's, I would say, steps number 3 until 6, where Cybellum is included. Hope this answers your questions. And we have more. It looks like, Michael, most of them are related to you. So.
Yeah, I'll go over them one by one. So
okay.
There's a question here that is there a possibility to include the supplier vulnerability database other than CVE, CW databases? So first of all, yes, we support also a custom CVEs or CWEs. This is something that you can insert via our GUI or via API. So this is something that can be done separately, but we also support a very large number of databases as of our own. This includes both the usual NVD, but also much less popular databases like CNNVD, which is the China database, JVN, which is the Japanese one. We are also having our own proprietary binary analysis engines for detecting CWEs, which are zero-day vulnerabilities. So these are detected using static and dynamic binary analysis in order to populate new CWEs. So in that sense, we have already quite a large range of databases and engines for default CVs and CWEs, but this can be extended quite easily to add custom ones that you might have in your organization. I hope that answered that one. We have here 3 questions that are related to the scoring in general. So one of them is, how is the score determined? Second one is quite similar. And the third one is also, are you developing a grade of what level needs fixing? So for example, 7 and up must be fixed. So let me just explain a bit more about scoring in general, and then feel free to add another question if I didn't answer. So regarding the score, we have our default algorithm for scoring, but this is something that is fully customizable. And so usually when we come to a customer, we are, as part of the onboarding process, we try to understand what are the security policies that your organization wants to create. So for example, an organization might decide that if there are at least 1 critical vulnerability, then the score must be lower than 7. A different organization might decide that the score that is unreleasable, that means dangerous, might be 6, and another one might be 8. So this is something that is fully configurable. We do have our default security score algorithm in case you don't have any policy in place, but this is something that we highly advise as part of the onboarding processes to understand what is important for you, and according to that to set the security algorithm to meet your specific policies. Do we have any more questions here? I saw these 3 about the scoring.
There is one question. How do you deal with intermediate status or discussed proposals for WP29 or ISO 21434?
Sorry, can you repeat that idea? I'm not quite sure I understood it.
Me neither. How do you deal with intermediate status or discussed proposals of WP29 or ISO 21434?
So I'm not sure I'm 100% understand the question, but I'll try to elaborate. And please, whoever asked this question, is the question asking how we're able to adhere, for example, to some of the rules and the regulations and not all of them, or how we're able to?
I think, Michael, the question is meant that it's not finalized, it's not published yet. So that means it's interims. And I guess how to deal with this interim status, because companies need already to work with that. But I think you mentioned before it will be released in Q3. Will there be major changes, or is there an expectation there will be major changes, or is the preliminary status already something companies can work with? That's how I interpret it. Maybe I'm wrong, Manfred, but that's the way how I read it.
Yeah, so obviously we can't know for sure, but from what we're seeing until now, because a lot of work has already been done into that, we do believe that the current status won't have too many changes. And we are following it closely, and we are actually, for example, part of the ISO committee. So this is something that we're not only seeing from our side, but we're also actively participating in. Obviously, any changes that are done in that sense is something that we are following in our product, and matching those changes in order to be able to give a full side-by-side coverage of the upcoming regulations.
And Adi, I think we skipped one from Amit. He's asking about
As per
certification.
CSMS mentioned in WP29, there will be certification needed. Does Cybellum have an idea who will be certification authority?
Currently, we are not performing any certifications by ourselves. Not sure exactly who will be providing the certification, but this is something that we will be inspecting once we reach a more, let's say, a mature state in the regulations and get to that at that stage.
We have another question. Do you import the published standards into RVNS to be used as starting points for the requirements tracing? How is that importing done in practice? Do you have any specific tools for getting the results at nicely structured data of the standards text into the RVNS tool?
Yeah, looks like I need to take this. There are different possibilities. As we described at the beginning, this partnership is new, so we have an idea how to do that. But of course, there are several possibilities. We at PTC, we have a tool called Process Director, where we already have system engineering best practices as well 26262 best practices. That's a central database with a web user interface, but that would be independent. That could be an approach. There's also the possibility that inside of Windchill RVNS, we define a specific document type. If we look at general at projects, we may have generic requirements which are handled on a central way. We have project-specific requirement, and maybe we have regulation or legal requirements. So depending on that, we can also set up different types of documents and link it together. So the question here is, I think, need this data to be traced inside the tool, or is it more a kind of advice, best practice and education, how the engineers should work according to the regulation? So I think there are different possibilities, but the good thing is, yeah, we have the choice, and depending on that, we can set this up. Last question, do you have a specific tool for getting the result as nicely structured data of the standard text into the RVNS tool? So the idea is not to replicate all the data. The integration is flexible. We can transfer additional data or also minimize. It depends on the use case. So the integration has, let's say, kind of parameters. You can define what attributes needs to be transferred at which moment. And depending on that, we can extend the reporting. So at the moment, like the system is set up, we have the detailed reporting of the security scan on Cybellum side. And we have inside of Windchill RVNS for the reporting, we have the summary, which is then linked to the Cybellum platform. So yes, there's also a way of reporting, and yeah, we need to take a look if this needs to be adjusted for a specific case, but it's possible.
Okay, another question that we have here is, are Cybellum and PTC financially tied into each other?
These are independent companies. We are separated.
Okay, I think it's the last question. How can you verify that all requirements of the standards are fulfilled in the standards data? Sorry, are fulfilled if the standard data is not put into the RVNS tool and can be monitored then there?
Yeah, exactly. That's a good question. So how to verify requirements if they are not part of RVNS? That's exactly what we need to figure out. What kind of data needs to be in the system? So if it's not there, it cannot be traced. There are possibilities, of course, of grouping, because if you go requirement by requirement, and it can be thousands of requirements, you may link them to a test case, you may link them to a test session. That's not feasible. So that means that there is an aspect at the beginning to determine what is the right level of traceability, because somebody needs to trace it because the system cannot know it. And that's something we can handle flexible, and we need to take care that all this information is part of the system, that it can be traced and compliance is given. And finally, there's nothing overseen. It's a bit like a traceability matrix for requirement, or also called requirement-based testing. So there are possibilities in the reporting to make sure, is there a link? And if there's no link, that's an indicator. It may not be the answer why there is no link, and maybe do we need more links? But if there is no link in the traceability metrics, that should be an indicator to look closer if this is a requirement which has been forgotten. Is this a requirement maybe we do not need? So, but yes, that's an important element to make sure everything is traced and monitored.
Okay, no more questions, and we are running out of time, so let's wrap it up. Thank you everyone for attending. Thank you, Michael. Thank you, Marcus, for giving us this presentation. We will follow up with all of you with a recorded version of this webinar, so you can re-listen. If you have any questions, feel free to reach out to either one, Michael or Marcus. And with that, that's it. Have a great evening.
Thanks for having me. Thanks for your attention.
Thank you, everyone.
Bye-bye.